Hi, everyone. My name is Andrey Nikitin. I'm a data science manager at Cyera. Very excited to be here. And yeah, 2 days ago, we had our child, our second one. That's why I'm here, because it's the second one. And yeah, so if I'm drifting off, be more gentle with me. Thanks. So first of all, yeah, let's talk about it. What are we seeing here? I will talk with you about our file classification model. But first, let's understand what is a file classification. Usually, when we talk about data classification, we think about, let's say, I don't know, a name, right? SSN, date of birth, everything you know from your Kaggle computations or whatever, from your plays with Spacey, any name entity recognition task, that you actually look for a specific type of entity. But when I talk about the actual file level classification, I want to know what is the document. And this is a death certificate, for example, as you can see here. So basically, we want to classify the type of document that we're talking about. And this is a quite common document in insurance company, health companies. One second. Yep. So before we dive deeper, not really deep, it's going to be very shallow, about the model, let me convince you on why it's actually a huge problem in the enterprise world. I will talk about 3 of our customers. First, a media giant. Any idea how much data types this customer have? A number, go ahead. How much? Okay, I'll be more specific. The type of document types the document have. A good number, great. Around 1 million type of documents. Now think about it. I want to classify this company, so good luck creating a taxonomy of around 1 million document types. Think about it. Let's talk about top 3 classifications. Okay, not the file. Again, the classification. An invoice, financial, again, makes sense. Purchase order. It's a media, let's say Netflix. It's not Netflix. But let's say it's Netflix. It makes sense. Health insurance from Fortune 500. Again, a similar numbers, top 3. It's going to be invoice. No, it's a bit more industry specific. So you can see already from even the most common documents, it's getting a bit different. So I'm not sure I would have guessed that I need to look at the insurance company, that I will need to actually find meeting summaries, for example. Now, a food and beverage company that specializes in soups. All of them, 10 billion plus revenue, stuff like that. Again, 500,000 invoices, but the second most common document, background checks. Why? They have tens of thousands of workers and they need to do background checks. Again, I would have never guessed that I will need to look in advance for this type of document. Okay, great. So we always see new types of documents, more niche. COVID, right? Before COVID, we didn't have COVID documents. Home pricing, a construction company, they'll have different types of construction documents. This is a snapshot from our own platform, from that media giant. If you look at the classifications, it makes sense, right? We have podcast agreements, film contracts, sell and deals reports. But again, think about what you had to do to know in advance that these are the documents that you're looking for. This is quite problematic. How do we get from the document itself to the classification? Input, any type of document, anything at Cyera, we always start separating it to structured and unstructured data. Everything structured is tables, RDS, JSONs, whatever. That's not what I'm talking about today. Anything related to unstructured data, any type of document, PDF, docx, whatever. We need to parse it. And again, it's a very hard job at an enterprise scale level. F10 companies, F15. It's not what you'd usually see At a Kaggle competition, very clean documents, very nice, with nice metadata. It's not like that. And then it needs to pass a lot of pipelines, OCRs. What's coming at the end of it, it's quite messy, and you have to work with it. The LLM inference itself, online inference at scale, hundreds of GPUs, generating the label. Do the guardrailing, we're talking about LLMs. Two things mostly. PII cleanup, that's what we worried about the most. We don't want the classification and name of someone, for example. And safety checks, what you know from any commercial LLM. I don't think it's that important, but Neta there think it is. You can ask her why she did it. But that's also what we need to do. And again, the output, what we, a final consolidated label. Why consolidated? Hold that thought. We'll talk about it in 2 slides or 3. How do we build the model? The most important thing, again, it's these two. It's the curation to have the most diverse, clean, as much industries as possible. I'm talking about hundreds of thousands, even millions of different documents of different types of classifications from different industries, of varied lengths, and as varied as possible. The labeling part. This is where it's getting tricky. You can use whatever you want. You can use open source models. You can use commercial models. And what we also like to do is you can actually synthesize the models for different classifications. For example, you know that a big customer from, I don't know, that's building LLMs themselves on board to your platform, and you usually want to also see those types of documents. You can use different LLMs to generate them, and with different rules to create different, let's say, types of trying to find the right word, to make it not as clean that you would get from a commercial LLM. Tokenize, you know that part. Fine-tune an open source LLM. We always fine-tune our models. We do a fully parameterized fine-tuning. That's an important part. LoRa doesn't work. I don't know if it's a nice toy example, but we usually fine-tune a fully parameterized fine-tuning. What LLM? That's not actually the most important part. Any usual suspect, when Llama can be decoder only, it can be encoder-decoder model. We have internally different type of models that different type of foundation models solve better. So sometimes Quen can do better, sometimes Llama, and sometimes Flantify, for example. Yes, if you even know that one. And optimized LLM. This is if you're not doing it in production, you're gonna have a bad time. Any text generation inference, VLLM, any type of those libraries, you need to run optimized models in production. Because after that, it still can cost you tens or even hundreds of GPUs in production. And why is this one is specifically different? We don't need to retrain each time we add new label. Again, think about it when we see a new label. We don't need to actually know, oh, did my model see it? Do I need to classify it again? Again, it handles any type of input text, and it can adapt to any type of documents it never saw before. And is this model perfect? Well, it is, but it still has some limitations. One of the most important ones, the granularity level. What do I mean by that? When my model says report, I can't do anything with it, right? Think about it. You do all this pipeline, and it says report. Thank you. But it doesn't help me that much. But then again, if it's this one, the blood test above the age of, the name of, again, I have nothing to do with it because it has very little value to my user, and I need to find the just right granularity level of the model. Again, a very challenging thing to do from LLM perspective. And the label synonyms. You see those two, they're practically the same. Sometimes I will have a document that's going to have a guide in it, and sometimes a manual. What do I do about it? And then I need to consolidate my labels. A more practical example, all of the four below you see there, I can have four of them. Both of them can actually be the confidentiality contract and the agreement. And then I consolidate them all four to non-disclosure agreement. How do we do it? Semantic clustering. Again, it's a bit voodoo, right? Anyone who worked with clustering on text to find what's right. I'm not getting into all the production aspect of it, the UX, the product, the scale. It's all different issues, but in essence, clustering. A bit marketing fluff. All of what I talked about it here is part of our all classification engine. A lot of AI words. Again, the very accurate data level classification, the file level classification that we just learned, and the structured learned. It's basically mean, don't worry about it. I know what's important to you as a customer. Don't tell me your special IDs, your special projects, any IP, internal IP, code names. I'll learn from the context. Don't worry about it and classify it. As a whole, we'll have the full holistic view of your data. On top of that, I know we operate in the AI security space, data security. I always say we're a data company because what we actually do, we create a very clear and holistic classification data layer. And on top of that, we build different pillars of security. But of course, we can do analytics, we can do data catalog, we can do whatever we want with that data. Usually, the buyer of the product will be someone from security, CISO, whatever, but a lot of the times it's the legal, analytics teams, even data science teams. And a fun fact, data science teams, as a target audience of our platform, are in a very bad position. They are really bad actors of data security. I'll let you figure out why. Thank you very much.